Hello everyone. Today's topic of discussion is another topic in this chapter number system. So what we'll be discussing today is basically how do we calculate the total number of factors. Okay. So how do we calculate positive factors? How do we calculate negative factors? Total number of factors, even factors, odd factors, and so on and so forth. Okay. Now, as far as GRE and GMAT are concerned, we don't get many questions from this topic. Okay, so however, you need to know the basics on how do we calculate the factors, because if in case it comes, you should know how to solve a question. Okay, all right, so let's begin. So let's say I start with a small number. Let's talk about the number 12. First question is how many positive factors of 12 are there? Okay. Now I'm using this word positive intentionally for the very fact that I told you at the start of this chapter number system, when we were doing the first basic video on number system, I told you that in case of GRE and GMAT, you have to consider both positive and negative factors as well as positive and negative multiples. Okay. We have to consider all those things. So we have to consider positive as well as negative. Anyway, so the first question is how many positive factors of 12 are there? So when you talk about 12, you can write 12 as 1 into 12, 2 into 6, and 3 into 4. These are the only three ways of writing 12. Okay. So if you talk about the positive factors of 12, there are like 6 positive factors of 12. There are 6 positive factors of 12. Similarly, there will be 6 negative factors of 12 also. There will be 6 negative factors of 12 also. For every positive number, we have a corresponding negative number. So for 1, we have negative 1. For 12, we have negative 12. For 2, we have negative 2. For 6, we have negative 6. For 3, we have negative 3. And for 4, we have negative 4. So whatever are the number of positive factors, that will also be equal to number of negative factors. So you can like make a note that number of positive factors for a number is always equal to number of negative factors for the same number. Okay, this is something that you need to remember. It's a simple thing. Okay, let's talk about 18. So if you talk about 18, so 18 can be written as 1 into 18, 2 into 9, and 3 into 6. Yes, so again you can say that we basically have like 6 factors, 6 positive factors and 6 negative factors, so like basically 12 factors in total, and positive and negative is 6 and 6. But let's say suppose I give you a bigger number. For example, let's say if I give you a number such as, let's say 250. Now how would you calculate total number of factors for this? Or for that matter of fact, let's suppose if I give you like 600, 720, 840, 1060, and so on and so forth. That can be anything. So the point is, how do we generalize, how do we actually find the number of factors? Okay, so now let's understand this. So in order to understand this, what we're going to do is we're going to understand how to calculate the total positive factors, and we'll try to calculate that for 900. Okay, I have taken an easy number so that you understand the concept. Then you can use the same concept for like complex numbers also. Complex in the sense like something like 1832 and all those things which are like difficult to factorize. That's basically what I mean by when I use the term complex. Okay, so first thing is we have to prime factorize 900. So again, prime factorization comes into the picture. Number system, more or less, it's all about prime factorization. You need to understand the numbers. Unless and until you understand the numbers, you can't move on forward. Okay. So 900 is like 9 into 100, which is 2 square into 3 square into 5 square. So if you want to calculate the number of positive factors, the first step is basically to prime factorize the number. It is to prime factorize the number. Now if you want to calculate the total positive factors, the formula is a plus 1, b plus 1, c plus 1, d plus 1, and so on and so forth. You can have e plus 1, f plus 1, and so on and so forth. Now what is a, b, c, d? When you talk about a, b, c, d, and so on and so forth, they are basically powers of prime factors. What is ABCD? ABCD is basically the power of prime factors. Okay, so in this case, you can simply say that A here will be 2, B here will be 2, and C here will also be equal to 2. C here will also be equal to 2. So what will be the total number of factors? So the total number of positive factors, it will be 2 plus 1 into 2 plus 1 into 2 plus 1, which will be equal to 27. Which will be equal to 27. And so you have a total of 27 positive factors. You're going to have a total number of 27 negative factors. Hence, the total number of factors will be 54. Hence, the total number of factors will be 54. That's your answer. This is how you would basically do it. So you can do it for another number. So let's say, for example, if I say, let's take 180. So 180 is 18 into 10. So 18 is basically 2 into 9, or 10 is 2 into 5. So 2 into 9 is 2 into 3 cube, 3 square, and this is 2 into 5. So this will basically become 2 square into 3 square into 5. So again, you can use the same formula. So that's a plus 1 into b plus 1 into c plus 1. So that will be 2 plus 1 into 2 plus 1 into 1 plus 1. So that's 3 into 3, that's 9. 9 into 2, which is 18. So there will be a total of 18 positive factors. There will be a total of 18 positive factors. So you have 18 positive factors. Similarly, you're going to have 18 negative factors. You're going to have 18 negative factors. Okay. So this is the process to calculate the total number of factors. Okay. Now there's something interesting which you need to know. Remember that if a number is a whole square, the number of factors will be odd. If a number is a whole square, then the number of, or let me write, the number of positive factors will be odd. And if a number is not a whole square, the number of positive factors is always even. Let's suppose if you talk about the number 64, or let's take 64 itself. So 64, it's basically like 2 to the power 6. So the total number of factors will simply become 6 plus 1, which is equal to 7. Or you can take 625, which is 5 to the power 4, and that will simply be 4 plus 1, which will be equal to 5. The reason being that is whenever you're going to have a whole square, whenever you're going to have a whole square or a square number, what's going to happen is whenever you're going to prime factorize, the power will always be even. The power will always be even. The power of the prime factor will always be even. And whenever we're going to add 1 to it, it will always result into odd. It will always result into odd. That's the reason. Okay. Now you can be asked like another different type of questions here. For example, let's say if I ask about 180, so 180 it's basically 18 into 10. So this will basically be 2 into 3 square, and this is like 2 into 5. So this will basically become 2 square into 3 square into 5. So let's suppose if I ask a question that how many odd factors of 180 are there? Or when you talk about odd, I can also ask like how many even factors. When you talk about even, why not about prime? How many prime factors? And you can also ask about like how many composite factors are there. So how many odd factors of 180 are there? How many even factors of 180 are there? How many prime factors of 180 are there? And how many composite factors of 180 are there? Okay. So let's see how we can solve this. So let's start with the odd one. How many odd factors of 180 are there? Now you need to know this. If you want the result to be odd, then the numbers have to be odd. Like what I basically mean to say is that if I like multiplying two numbers, let's start with multiplication of two numbers. There are only four things which are possible. First number is even, second is also even, first is even, second is odd, first is odd, second is even, first is odd, and second is also odd. Like if you're going to go for three numbers, you're going to have like 8 number of cases. In this case we have like only 4 number of cases. Now for the first three, the product is always even. For the first three, product is always even. It's only the last one for which the product is odd. So if I want to calculate how many odd factors of 180 are there, I'm gonna use only the odd factors of 180, which is 3 square into 5. Okay. So for 3 square into 5, the total number of factors will be 2 plus 1 into 1 plus 1, which will basically be 3 into 2, and that will be 6. And that will be 6. Next one is you want to calculate total number of even factors. Okay, now one more thing. What I am calculating, it's only for the positive part. For the negative, simply multiply it by 2. Okay. So total number of odd will automatically become 12. Now if you go for even, there are a couple of ways of doing that for even. One is you calculate total number of factors and then subtract odd number of factors from there. That's one of the ways, because the factors will either be odd or even. Like there is no third thing, right? We have only two types of numbers when you talk about integers. If you want to look at a different way of solving this, what you can do is, if you want the result to be even, if I want result to be even, what I'll do from here is that I'm going to take 1 2 common, and I'm going to rewrite this as 2 into 3 square into 5. The reason of taking 1 2 common is that whenever we're going to multiply a number by 2, whenever we're going to multiply a number by 2, it will always result as even. So whatever total number of factors you're going to get from this, whatever total number of factors you're going to get from this, you multiply it by 2 and you'll get even number of factors. Or you're going to get the result, the factor that you'll get will be even. My bad, not even number of factors. The result that you'll get will be an even factor. Okay. So here the total number of factors will become 2 into 3 into 2, which will simply be equal to 2. 2 into 3 into 2, which is equal to 12. Okay, so you're gonna have 12 even factors, and again that's again the positive side for negative multiplied by 2. Okay, so even you can do it like total minus odd, or if you want to calculate odd, then you can also do total minus even. Whichever way you're comfortable, please go ahead with that. I find calculating odd easier because you just have to take the odd factors into consideration with their power, so I just find that easier. Otherwise it's completely your call, it doesn't really matter. Okay, next one is you have to calculate the total number of prime factors. Now when you talk about prime and composite, as I've already told you in the first video, that prime and composite is a concept for positive and negative numbers. It's not applicable for, oh sorry, my bad, prime and composite is a concept which is applicable only for positive number, it's not applicable for negative number. So in this case, in case of prime and composite, do not multiply it by 2. Okay, that multiplication with 2 is only applicable for odd and even, it's not applicable for prime and composite, because negative numbers are not prime and negative numbers are not composite. Okay, now when you talk about prime numbers or the prime factors, there are only 3 prime factors of 180. One of them is 2, another is 3, and another is 5. 2, 3 and 5. So how many prime factors are there? There are going to be total of 3 prime factors. Okay, they're going to be a total of 3 prime factors. Now when you talk about composite ones, in case of this, remember that composite factors is always total number of factors minus prime factors and 1. And 1. 1 is also a factor of 180. 1 is neither prime nor composite. 1 is neither prime nor composite, so there will be a total of 14 composite factors. Usually students forget about this one and they simply say that, okay, number of composite factors will be total number of factors minus number of prime factors, which will be factually incorrect. Okay, which will be factually incorrect. Okay, so total odd is 12, positive odd is 6, total even is 24, positive even is 12, total prime is 3, and total composite is 14. Okay, all right, so this is more or less sufficient for your exam. You don't have to know anything more than this, but they don't generally ask questions from this topic. Okay, this is the extent of it which you need to know. There's a lot more which you can do in this, that is when you talk about calculating factors, but anyways we are sticking with our curriculum, so we'll stick to that. Okay, all right, now let's move on to the questions. So how many factors of 1080 are perfect square? So let's see. When you talk about 1080, so that is 108 into 10. So 108 is 27 into 4. So that is 2 square into 3 cube, and 10 is 2 into 5. So the result of this will basically become, okay, this will be 3 cube, that's 27, right? So this is 2 cube into 3 cube into 5. The question is how many factors of 1080 are perfect square? Now you want a perfect square. If you want a perfect square, the power has to be even. Okay, the power has to be even. Then only you're going to get a perfect square. So that when you're going to square that number, you should also get an integer. That's basically the whole point is, for example, when you're going to square root 64, you end up getting 8. When you square root 100, you end up getting 10. That's what the point is. So how many factors of 1080 are perfect square? So in this case, what's going to happen is I have 2 cube, 3 cube and 5. Now 5 will not help me in giving a perfect square because it has a power of 1 only. So it's not going to help me. I need at least 2 5s so that when I'm going to square root 5 square, it's going to end up with 5. That's the whole point, okay? So I can have even power from here and I can have an even power from here. So rather than writing this as 2 cube, 3 cube, let me simply write this as 2 square, 3 square. Let me simply write this as 2 square, 3 square. Or since I want a whole square, so 2 square to the power 1 and 3 square to the power 1. Because once these are squares, right? These are squares. So when I'm going to take the under root, it will automatically be like non-squared. So 2 square to the power 1, 3 square to the power 1. So it's basically something like p to the power 1 and q to the power 1, where p and q are whole squares. So that when I square root them, they end up giving me an integer value. So the total number of factors will simply be 1 plus 1 into 1 plus 1. Because 2 square has a power of 1, 3 square also has a power of 1, which will give me a total of 4 factors. Which will give me a total of 4 factors. Okay, so there will be 4 factors of 1080 which will be perfect square. Okay, I can give you the exact numbers also. 4 will be there, 9 will be there, 1 will be there, and then 4 into 9, 36 will be there. 36 will be. That's the answer. Okay, so it's just logic, nothing else. Okay, let's move on. Again, another question. So pause the video and try this one. This you'll be able to solve. How many factors of this number are perfect square? So I just need an even power. So rather than writing it as 2 to the power 5, I'm going to write this as 2 to the power 4 into 3 to the power 6 into 5 to the power 4. Or you can write this as 2 square whole square into 3 cube whole square, or my bad, it should be 3 square whole cube, and 5 square to the power 2. So 2 square can be written as p, so that's p square. 3 square I'm taking it as q, so q cube, and then 5 square I'm taking as r, so r square. Now these numbers p, q and r in themselves are a square. Okay, so they themselves are a square, so I don't have to worry about what answer would I get when I'm going to under root them. Okay, I don't have to worry about that. So the number of factors will become 2 plus 1 into 3 plus 1 into 2 plus 1. So that's 3 into 4 into 3. 3 into 4, that's 12. 12 into 3, which is 36. There will be 36 factors which will be perfect square of this number, whatever it is, 2 to the power 5 into 3 to the power 6 into 5 to the power 4. See, again, coming back to the point that I told you in the start of the first lecture of number system, the concept looks very simple. In this chapter we have to cover a lot of things still, The concept looks really simple, but when it comes to the questions, it's not easy. And this is the reason it's not easy, because you have to think it through. It's not going to be straightforward, trust me. Okay. All right, let's move on. Okay, pause the video and try this one. So how many factors of 3 to the power 4 into 2 to the power 3 into 13 to the power 4 are odd numbers? Now you know what you have to do when it comes to odd numbers. Only take the odd factors into consideration. So already prime factorization is given to you, so you don't have to worry about it. So you'll simply take 3 to the power 4 into 13 to the power 4 into consideration. So that's 4 plus 1 into 4 plus 1, which will give you like 25 odd numbers. Okay, now you can do like 25 into 2 if you want the negative also to be taken into consideration. Okay, so let me give you a question. So what I'm gonna do is this is like your homework question. So if you're done solving, once you solve it, let me know the answer in the comment box. So instead of 13 to the power 4, I'm doing it 12 to the power 4. So the number is 3 to the power 4 into 2 to the power 3 into 12 to the power 4. Apart from like changing from 13 to the power 4 to 12 to the power 4, everything else remains as it is. There is no change. Okay, so try this one and let me know the answer in the comment box. I'll wait for your answers. Okay, pause the video and try this one. Okay, so what I'm gonna do is I'm gonna take 5 to the power 9 common. This will become 1 plus 5 square plus 5 to the power 4. This is 5 to the power 9, 1 plus 25 plus 625. This is 5 to the power 9 into 631. Now we're looking for like prime factors of this number. Now 631 cannot be prime factorized further, it's a prime number. Okay. So there are going to be like two prime factors for this number. One will be 5, another will be 631. And that is your answer. All right, let's try another type of a question. Okay. So let's see what we can do with this one. So how many integers from 100 to 20 inclusive of both are multiples of either 3 or 5? So I'm looking for numbers which are multiples of either 3 or 5. Okay. So let's first of all start with multiples of 3. Now, when we start from 100, the very first multiple of 3 will basically be 102. The very first multiple will be 102. The next one will be 105, then the next one will be 108, and so on and so forth. It will be up till 198. 198 will be the last multiple of 3. So this is a sort of an arithmetic progression where your first term is 102, your common difference is 3, and your last term is 198. So you can say that 198 will be equal to 102 plus n minus 1 into 3. This is something that we learned in AP. An is equal to a plus n minus 1 into d. So this will basically become 96 divided by 3 is equal to n minus 1, and n will be equal to 33. Okay, so numbers which are multiple of 3 are 33. Next is multiples of 5. So in this case you'll be starting from 100, 105, 110, and you go up to like 200 because it says that inclusive of both. So I'll take 100 as well as 200 both into consideration. So you're gonna have A, which is 100. You're gonna have D, which is 5. You're gonna have AN, which is 200. 200 is equal to 100 plus n minus 1 into 5. So that's 100 by 5, which is, so n will be equal to 21. So n will be equal to 21. Now the problem here is that, see, the question is, it says either a multiple of 3, multiple of either 3 or 5. That's what the question is. So I don't want to count those numbers which are basically multiple of 3 as well as 5. Okay, so I need to remove those numbers. So I need to basically start, I need to understand which all numbers first of all will be a multiple of 3 as well as 5. So those numbers will basically be multiple of LCM of 3 and 5, which is basically 15. So the very first number, which is a multiple of 15 greater than 100, will be equal to 105. Then it's 120 and it goes up to 195. So 195 is equal to 105 plus n minus 1 into 15. So n will be equal to 7. So there are basically 7 numbers which are multiple of 3 as well as 5. Now I can say that 33 plus 21 minus 7. Now, or let me put it in another way, I need to remove this 7 from this 33 as well as from this 21, because I want numbers which are either multiple of 3 or 5. Either a multiple of 3 or 5. I cannot take those numbers which are multiple of 3 as well as 5. So I have to remove those 7 numbers from multiples of 3 as well as from multiples of 5. So my answer will simply become 33 minus 7 plus 21 minus 7. So that will be 26 plus 14, and that's equal to 40. 26 plus 14 and that's equal to 40, and that's your answer. Okay, if the question was multiples of either 3 or 5 or both of them, see, understand, if the question was multiples of either 3 or 5 or both of them, in that case you would be subtracting 7 only once, because those 7 numbers are part of 33 and those 7 numbers are also part of 21. Those 7 numbers are part of 33, those 7 numbers are also part of 21. That's why now I can't count a number twice. That's why I'll be subtracting 7 only once in that case. In here I'm subtracting 7 from both 33 and 21 because I don't want multiples of 3 and 5 to be taken into consideration. Okay, so you need to understand the question. That's important. All right, let's move on to the next one. Okay, pause the video and try this one, please. All right, let's see how we can solve this one. So 81 to the power 11 is divisible by 3 to the power n, then find the maximum integer value of n. So this will basically be 3 to the power 4 whole to the power 11, which is divisible by 3 to the power n. So this will become 3 to the power 44 divided by 3 to the power n. So find the maximum integer value of n. The maximum integer value of n will simply be 44. Because if you go anything above 44, like let's say 45, 46, then you will not be able to divide 81 to the power 11 by 3 to the power n. Okay, then you won't be able to divide that. Okay, so let me give you a homework question so that you can try that for yourself. So everything is same, it's just that instead of 3 to the power n, here we have 27 to the power n. Try that one. Okay. Okay, pause the video and try this one, please. So how many even integers from 37 to 62 are squares of integers? Okay, are squares of integers. How many even integers are squares of integers? Okay, so before 37 or closer to 37, I have 6 square, which is 36. Then I have 7 square, which is 49, and so on and so forth. There's no point of writing down all the numbers. And closer to 621, we have 25 square, which is equal to 625, which is equal to 625. So which means I have to start with 8, then 10, then 12, and I have to go up till 24. So you have A as 8, An as 24, and D as 2. So 24 is equal to 8 plus n minus 1 into 2. So n will simply become, this is 16 by 2, that is 8, 8 and 1, that's 9. There are like 9 even integers which are squares of integers between 37 and 62. Okay. So this is more or less sufficient as far as this topic, how to calculate factors is concerned, because we don't expect any questions, as I've already told before. So thank you so much for watching the video. Please subscribe to the channel if you haven't, for more videos and exam related content. And if you have any doubts, if you have any queries or questions, you can like mail us or you can WhatsApp us. You can also drop in the comment box. And if you're looking for the personalized classes for GRE, GMAT and ACT, then you can always connect with us. All right. Okay guys, thank you so much. Keep watching and keep learning. Thank you so much.